I've been invited along today by the Essex Employment and Skills Board to talk about Internet of Things, artificial intelligence and big data. As I'm sure you can appreciate, these are big subjects of their own, so we could have 3 separate talks about these, but what I'm hoping to do is give you an overview as to what they are and how they're already entering lives, the opportunities that are there, and actually what's going on in the market. When you speak to most people about artificial intelligence, they think of this robots that are going to take control of the world and eventually decide that we don't have a relevant place for it, and have a sort of conscience, sentience and a mind. This technically is known as strong AI or artificial general intelligence, and while there's a lot of research into that, we are a long way off of there. That doesn't mean to say that the safeguards and policies, and there's even Lords committees looking into this to making sure that rules are defined and so forth aren't valid, but actually for this coming around the corner in the next 5 years, it's just not going to happen. But actually many of the existing systems that are out there that scream they've got AI in aren't strong AI, they're actually known as narrow or weak AI. And what they are is they're as the name suggests, they're focused on a particular application and doing a specific defined problem. And that is very clever in itself. So examples of that, well, you're probably carrying an AI example in your pocket today, which is sort of Siri, or if you're more of an Android kind of person, is Google Assistant. And equally, these AI technologies are starting to appear more in the home. So this is a Nest thermostat, which after a couple of weeks of operation of you setting the temperature, then starts to intelligently know how you'd like to be more comfortable. But we didn't start there. Actually, the first AI examples came about by us providing coding rules to machines. So the thought was that actually a lot of what's in our head is just all rule-based. So if we write out lots of rules, we can, create intelligent machines. And and this is now known as classical AI. And one of the big draws at the time was chess. And so these rules were applied to chess to try and create a system that you just simply want to beat. The problem with this approach is that the possibilities and the combinations that you have to examine grow exponentially, or is called a combinatorial explosion. And if I go back to the chess example, so at the start of the game, just one move generates 400 combinations of playing. By 2 moves, that's 200,000 different combinations. And then just by 4 moves, there's tens of billions of combinations that you could play with chess. So no human or even modern day computer can tackle this with any time frame that's going to be useful for playing chess. Yet we still all play chess. So how does that work? This problem fascinated Alan Turing of Bletchley Park. He actually turned his mind to this and proposed a set of rules to guide the computer. And these rules are kind of high-level guides that the chess program would move to. They're known as heuristics, and they're the way for the program to prune down the number of possibilities and then make a choice on that side. So for example, one of the heuristics is to always consider capturing an undefended piece. And by adding some of these in, instead of having to code every single rule, you were able to have these certain rule points and then decide to go forward with them. In 1948, he came up with this idea and even a program to do it. It's called ChuroChamp, but obviously in 1948 there was no computer to run it on. So he did it all with pencil and paper, and it wasn't until 2001 or it might be 2010 that the actual ChuroChamp was played against Garry Kasparov, and Garry Kasparov won, but it came very close to doing that. So that kind of way of using heuristics in coding rules was very powerful, and indeed is used on a lot of things like Siri and so forth. So while it appears to be intelligence, there's a set of rules that you're going through, and that's why you eventually can come to a funny end. But as I mentioned, this runs into issues when you get into more complex situations. So as we know, the real world is messy and really complex. So what's really driven things forwards in the last decade or so is machine learning. So instead of us trying to give computers all the rules to handle a situation, computers learn how to make sense of the world themselves. There are lots of different aspects to machine learning and AI, but two areas I find really interesting are supervised learning and unsupervised learning. Google have developed an open source machine learning framework, which is an example of supervised learning. And basically what I mean by that is you're able to train it with a set of data. So in the example I'm going to give you, the TensorFlow library has been programmed with roughly about 2,000 photos, and it's for detecting various objects. And what it happens is the program runs, and the user sits there and says, yes, that is a dog, no, that is a cat. And the rules actually within the machine learning form themselves so that the user is able to get a display of what's going on. So this is an example of unsupervised learning. So a British AI company called DeepMind set a machine learning challenge for it to play Breakout, and basically it didn't give it any of the rules. They said all that was there was when your score gets better, what happened, and when your score gets worse, what happens, and you decide what to do. So after about 300 games and it missing, it starts to get to human level performance. So what you're seeing is quite a good human player. But what was interesting, when they got to beyond that, sort of 600 plays, it created a strategy completely of its own, which is now known as tunneling. And what you can see is it's created a tunnel here and has shot the ball behind it. And it's worked out that this has the max reward for the minimum risk. Now, this was something the programmers weren't expecting at all. This is completely machine thought out. But is an example where actually machine learning can benefit us on that side. So a lot of the time it's sort of shown that AI is going to be detrimental to human endeavour, but actually through examples like this, and okay, I know it's only playing the game of Breakout, it's worked out a strategy that is quite revolutionary and efficient on that side. And so if you turn that to other industries and things that were happening, what other things have we been doing the way we've been doing them for years, but just purely out of humans repeating themselves? Some of the areas where machine learning is being taken forwards are on medical imaging. So IBM Watson is working on a project with a few of the NHS foundations into looking for brain cancers and so forth. And again, at first this started off as, well, look, we can get rid of all the doctors and consultants, we'll have this computer looking through all these medical images and discovering all the things they've done. But actually the value that they found is having the machine learning sitting alongside a consultant, and not only is the consultant helping with the supervised learning and improving that side of things, but the machine learning algorithms are bringing out areas for consultants to perhaps take a look in more detail and to just up the success rate of the trials on that side. You probably all heard, well, you may not have, Waymo is the Google AI driving self-driving car, but Oxbotica is an Oxford-based self-driving technology company. Again, they're using machine learning to improve the self-driving algorithms. They haven't taken the view, which I think is sensible, of the Teslas of the world, is that this has got to a point, let's put it out on the roads and see what's happening. They're actually building up the experience and the machine learning on that side. And recently Addison Lee announced that they're going into partnership with Oxbotica to try and start offering taxi and courier services on set destinations to improve this technology. And then one that's probably far more in our lives is spam filters. And the reduction in spam has been, one, down to actually targeting people that are sending unsolicited emails, but two, machine learning actually being put into spam filters to make sure that you get messages through to them. And again, this goes back to the supervised learning that I was talking about earlier. So basically, what a lot of the programs do now, without you realizing, is that when you start a new email program, a new email account from scratch, you keep the emails that are technically good emails and you delete or spam filter the others. And slowly a sample builds up of what are considered good emails and what are considered spam emails. And this is a form of supervised learning that then the program can take forwards and start to structure things. So this is the one I constantly come across with AI, is that robots and AI will take all our jobs. Honestly, I think we have to be realistic. Jobs will disappear, but new jobs will come along too. When industrial automation came in, that replaced jobs, and some very dangerous jobs at that point. But it also created new ones. And the same happened with computers. New jobs came around because of computers, and jobs now that you can only do with computers. I mean, take, for example, digital marketing. I mean, that just didn't exist before there was the computers and the internet on that side. And even in this sector, there's machine learning engineers, there's, again, the data scientists come up, there's R&D engineers. So there's lots of new jobs that are being created. While there's been massive leaps and developments in it, we still can't do anything like a 2-year-old can, and that learning that they have, there's something that we just don't get on that side. So I think actually bringing in education to some of these technologies could be an interesting mix too.